Alright, so in this video, we're looking at recurrence relations, and specifically at how to find the first terms in a sequence from a recurrence relationship formula. So a typical question will look something like this. Find the first four terms of the following recurrence relationships. And for part A, it says that u of n plus 1, so basically the next term in the sequence, is equal to 2 times un, so 2 times the current term in the sequence, plus 1. And they're telling us that the first term is a 2. So what I'd do here is I'd write down the formula, and I'd write down what u1 is, and I'd put u2, u3, u4, because these are the first four terms that we need to find. Now remember, recurrence relationships aren't anything kind of different or special. They're just a different way of writing an arithmetic or geometric sequence by telling you how to find the next term in the sequence based on the current term. So think of un plus 1 as the next term, un is the current term. So we already know the first term here. So if I want to find the second term, u of 2, I'm going to do 2 sets of u1. So I want to find the next term, so do 2 times the current term, add 1 more. And here that means 2 times 2, because the current term, the first term, is 2. Add 1, which in total is 2 times 2 is 4, add 1, 5. So u2 is 5. Then we do the same thing next time. So u3 is going to be 2 sets of u2, which is 5, so 2 times 5. Add 1 extra. 2 times 5 is 10, add 1 is 11. Scroll down a little bit. And then if we want to find u4, we just do 2 times u3, which remember was 11, that we just found. So 2 times 11, add the 1. That means 22, add 1, so 23. So this first sequences here are 2, 5, 11, 23. Now this here isn't really perfectly an arithmetic or a geometric sequence, but it is a sequence of numbers. There's a pattern. Basically what we're doing is we're doubling the number and adding 1 more. That's what this means. So double the previous term, add 1 more. And that gets us our first few terms. Okay, then for part B, I've written this out down below. So let's just scroll down to here and do this one. So for part B, they're telling us that u of n equals un minus 1 squared minus 1. So this is the same idea as last time, except they're kind of saying that the current term is the previous term squared minus 1. So it doesn't matter that they're using n and n minus 1 rather than n plus 1 and n. It's kind of the same thing. So if we wanted to find u of 2, the second term in the sequence, we would just do u of 1, because 2 minus 1 is 1, squared minus 1. And because the first term they told us is 2, that means 2 squared minus 1. 2 squared is 4, take away 1 is 3. So that's 3. Then to find u of 3, the third term, I just do u2 squared. So we found u2 was 3. I do 3 squared minus 1, which is 9 minus 1 is 8. We pop 8 up here. And for u4, we do 8 squared minus 1. 8 squared is 64, take away 1, 63. I found it 63. And that's it. So remember, for these recurrence relationships, you're just finding the next term in the sequence using the previous term. And it doesn't matter if they're representing the next term as un plus 1 or un. It doesn't really make any difference. You just plug in the first value to find the second one, do it again to find the third, fourth, and so on. And that's it. So I hope that's all made sense. Have a go at the questions down below, and if you have any questions, just let us know. Thanks.